All right, guys. Yes, I think we are live. Okay, just double checking. All right. Hi, everyone. Welcome, welcome. So today we'll be building a multi-chain smart smart contract with Interchain Token Service, and I'm pretty sure like you guys can hear me. So I'm live right now. Yes, GM. I'm seeing comments coming in. Yeah, GM guys. So yeah, today we're building a multi-chain task contract with Interchain Token Service. I think this could, you know, you learn different approaches on how you can add fees or like create a fee mechanism into your multi-chain task contract. And then we'll learn about how you can do this. We go into the demo session where you can have practical implementation and all of that. Right. So let's get right into it without wasting much of our time. All right. My name is Idris Olubisi. I am a software engineer and a technical writer. I am a developer advocate at Interrupts Lab working on Axela. And you can find me on any socials at Olanesoft. So, what are we going to cover in this workshop? We'll take a look at Interchain Token Service. What exactly is Interchain Token Service? The background context. Don't worry if you are just hearing Interchain Token Service for the first time. It's all good. I'm going to give you a step-by-step guide and then what you need to know about Interchain Token Service. We'll also talk about Interchain Token Service Decision Tree, where you can see some of the features available to you and then how you can make informed decision about the particular feature that you might be interested in and then what would fit into your own use case. And then we move into the actual contract. We talk about the task contract, how you can create a few mechanisms, what are the things you should know, what are the key components of the task contract, and then what you should look out for. And finally, we go into the demo session where we can demonstrate everything live, build from scratch, and at the same time, demonstrating everything live, build from scratch, and then at the same time, test them so that we are sure that we can achieve the same result. So let's get right into it. So talking about blockchain, it's like having many countries with its own money. At first, these countries couldn't share their money easily, but if you had tokens from one place, you couldn't use them in another chain, which is another country. In this example, people wanted to change this, right? They thought, what if I could use my token anywhere? Like we have this token and they want to use it anywhere. We want to maintain the same functions, like want to make it functional across all the blockchain and also maintaining the fungibility and also some custom integration intact. This is where our story starts. We want to make a special tool in such a way that see it as a magic app that lets tokens travels between different blockchain, which is different countries in this example. But then there is a catch. When user uses this application, they pay a small fee. And then in this scenario, this is a small tax. Why are they paying this small fee in the first place? Well, think of it like a toll, and this money can help get things up and running smoothly. And then you can also use it to reward people who owns this token or like use it as a governance system, use that particular amount if there's no need to have it anywhere. But then why do you today we are going to build this application. We will use Interchain Token Service a tool that will help us make all of these things happen in a seamless manner. So get ready. We are about to create something really, really exciting. And I'm very sure that you all will enjoy it and also enjoy the process of integration. And this integration will let our tokens travel anywhere, but always remember where they came from. Of course, we want to have assets that can be useful across different protocol, right? So, Interchain Token Service. What exactly is Interchain Token Service? Interchain Token Service is a service, it's a tool, it's a suite of tools, and a smart contract that is designed to empower developers to issue, manage tokens, and also retain their utility and fungibility across multiple blockchain ecosystem. But you also need to understand that there is a laid emphasis on issue and manage token, and also retaining utility and fungibility across different blockchain ecosystem. So this means that if you have custom implementation that is peculiar to your use case, you can keep all of this functionality intact and be rest assured that as your token move from one protocol to the other, all this implementation are kept intact and also functional across all of these chains. What are some of the features you should look out for that Interchain Token Service currently offers that you can get, out of the box? First is fungible, right? Fungibility. You can easily scale up to 15 plus blockchain with canonical versions of your token that shares the same EVM address across all the chains. Second one is no code. Only multi-chain tokens fully automate permissionless multi-chain deploy and management where you can leverage the Interchain token portal. We understand as a developer, you want to have full control of what you can build. You want to programmatically do things, build stuff on your own. But at the same time, we also provide a portal for people that want to quickly go to market and then they don't need to have technical experience before they can create their own multi-chain token or deploy their token across different chains. That's why we have the Interchain Token Portal. And to access the Interchain Token Portal, you can go to interchain.axelar.dev. And then the next point here is trustless. Multi-chain tokens run on open source code via smart contract on a public blockchain that is secured by a validator, a dynamic validator set. Which blockchain am I referring to here is the Axelar network. And then the last point here is functional. I mentioned keeping customization intact. Multi-chain tokens are customizable with features like yield, permissions, going cross-chain with customizations intact. So you are rest assured that as your token move from one protocol to the other, you can keep your customization across all of these chains at the same time. So now let's talk about the decision tree that you have. There are so many other use cases that you can think about, that you can think of rather. And then these use cases are peculiar to different protocol at the same time, right? So in as much you have like different use cases, how do you make informed decision about which service you should go for, like which features is available to you when you want to leverage the Interchain Token Service? So there are two things to take note here. The first is you want to create a new multi-chain token, right, from scratch. It has never been deployed before. You want to deploy a brand new token, and then you think about multi-chain from the beginning. The second point is you want to upgrade an existing token. You're already doing, volumes. You have your token on one chain. You want to deploy on multiple, other chains, or you have your token on 2-3 chains, and then you want to go as far as 15 plus chains that Interchain Token Service currently supports. All of these things are something you can do by just leveraging the Interchain Token Service contract with ease. So now let's talk about the first one, which is creating a multi-chain token. This is the first point, right? And how do you do that? The first question is, does your token need a custom functionality Like, do you need a customization for your token? If your answer is yes, then all you need to do is to build a custom ERC20 token and then make it an interchain token or multi-chain token in this example, right? But if the option is no, you don't need a custom features, like you're good to go with the default ERC20 token, and you want to just like you are good with the default ERC20 token and you want to go ahead and just deploy your token. We have the option of using the Interchain token portal, which I mentioned earlier on, interchain.axelar.dev, or you do it programmatically, right? So programmatically in this case means that as a developer, you want to programmatically interact with the API yourself without using any public interface. You can just go ahead and then do that. Now, to the second option, you want to upgrade an existing ERC20 token. You already have a token in production, and then you are looking to upgrade the tokens to, a multi-chain token that can be deployed across different blockchain. First, another question to ask: Do you have your token deployed natively on multiple chains already? Maybe you have it deployed on, Binance and then Avalanche, let's say, for example, and then you want to link them together. Or let's say you have on Base, you have on Avalanche, you already deploy your tokens everywhere, and then you want to link them together as a multi-chain token. Then that's quite easy. All you just need to do is to deploy the tokens on multiple chain. Just link the deployed tokens on multiple chain as a multi-chain tokens, right? That's interconnected, leveraging the Interchain Token Service. But if your option is no, you don't have a token deployed already on multiple chain, you only have it on one chain, then the option to think about here is using the canonical token as a simple wrapper option. And you can, deploy it programmatically, which is the same as leveraging the Interchain Token Service API that is available to you, or you use the portal. Remember, doing it programmatically as a developer, and also if you don't have technical experience and you just want to try things out, you can go to interchain.axelar.dev. This is the mainnet. You also find a link to go to the testnet there where you can play around with things, see how things works on testnet, and then finally go on mainnet to deploy your token. So I'll pause here a bit and see if we have any question. All right, I'm taking a look. All right, no question. So now that's clear. I can proceed. With all of these that I mentioned and then explain, if you're still confused, right, which is normal, right? There are so many options, there are so many ways to think about it. Don't worry, we got it covered. We have a well-detailed documentation that you can access as docs.axelar.dev. You can find a step-by-step guide on different integration options that I mentioned, so you can pick an option that better suits your need and also use case. So visit docs.axelar.dev. You'll get like full detail about what you need to know, and also reference to our smart contract that is open source that you can verify all of these things. And for knowledge purpose, for educational purpose, you can also look through some of these contracts and see how the implementation was done and then what exactly is going on under the hood. So now let's talk about building a task contract, which is the whole point of this workshop today. What do you need to know about the task contract? What exactly is the task contract in the first place? So what is a task contract? I mentioned task contract. You might be wondering, what exactly is that? What does it even mean to build a task contract? So let me give you a scenario, right? Imagine our task contract that we want to build today in today's workshop. Imagine it as an international airport with multiple terminals, right? While each terminals represent a different blockchain network. Now think of our tokens as a traveler that is moving between these terminals. So in the airport, there is a special service that helps traveler to move seamlessly from one terminal to the other, even if they are in different countries. This is exactly like our Interchain token service. Now, Just as airport charges small fee when you use a certain services or facility, our tax contract applies a simple fee when a token travel between different blockchain, in this case, between different terminals, right? Let's say a traveler, our token, wants to go from terminal A, in this example, Ethereum, to terminal B, to let's say Base or Avalanche or any other, network. They use this special interterminal transport service, which is our tax contract that we'll be building. So as they make this journey, a small fee, which is called like a transit fee, is automatically deducted. So these fees could be used in various ways, depending on the use case of that particular tax contract. So it can be used, it can be borne, like how some airports uses fee to offset carbon emission. You can just burn the fee on chain, or it could go into travelers reward program if there's a particular reward program for frequent travelers. So there can be a reward pool that these fees will be transferred into, and then get to reward the travelers at the end of the day. It might be used for airport maintenance and expansion also. So project treasury, liquidity pools, governance, all of these things, you can remit those funds, like the fee, deducted directly into those wallet addresses or a multi-sig address. The beauty of this system is that it works the same way no matter which terminal, which is no matter blockchain network that you're on. The token, in this case, the traveler, is moving between, no matter what the traveler, like the different terminals the traveler is moving in between. It's a universal system that makes crossing movement very easy, and then working from one airport terminal to the other. This airport as an example where you could have different terminals and then still be able to, use your token, and at the same time, a fee for using extra services is deducted while you use those services, and you can still move in between different blockchain at the same time. I hope you guys, understand what I mean now. So let me check again if we have question. All right, no question. So we can proceed. Key component of a tax contract. What exactly do you need to be aware of when you're thinking about, tax contract? We have three things I've highlighted here. You could have a very long list, but three main things here is, number one is you have the ERC20 token standard functions. So just, the functions for ERC token, that is the standard everywhere. Number two, you have the Interchain Token Standard integration. So Interchain Token Standard integration is, Interchain Token Standard itself, it's a contract that serves as a standard that you can extend into any token that you are currently building. So this contains like extra features like transfers, things that you can just easily extend and then utilize on your contract. And then we have the fee calculation and application. Of course, now you've built the contract, you have the ERC20 token standard, you have the Interchain token standard, and then you need to talk about the fee calculation and application. So how do you want to deduct? Do you want to deduct 2% of every amount that is transferred, or deducted, or depending on what use case you are using? Is it 2%? Is it 5%? Is it 10%? Is it 50% of any amount that is being transferred? Then you can directly deduct it from that, amount that is being sent from one protocol to the other. Let's talk about the fee mechanism option. Those are the key components you should know. But what exactly, do we have any fee mechanism option that you should think about when you want to build a tax contract? Yes. Number one is sending, whenever you deduct that fee, you want to send it to a reward pool, or you want to allocate it to a particular treasury. You want to add to a liquidity pool. You want to use it for cross-chain remittance services. You want to use it for platform maintenance. There are a lot of use cases that you can use this fee for, depending on your own particular need, right? When I mean your own, I'm talking about your project. So because we've seen like a lot of our developers and also builders in the space keep asking about, now I've integrated ITS, I want to be able to tax my user. This is why we are doing this, right? learn how to tax your users depending on the value you are providing and how much you want to, tax them. So this is something that you should really be excited about, because I'm really excited about this, but you should also see how powerful it is for you to leverage Interchain Token Service and still be able to achieve these tax or fee mechanisms within your contracts with ease. So I'm going to check again if we have any question. Yes, we don't have question, but I think we have a contribution. Yeah, GM is a GM artificial period, GM Galen. Yes, that's interesting. Yeah, in general, what can be done with Axela in a couple of years of the paradigm today? Most developers build a dApp, then think bridge. So even integrating bridging into a dApp is a next level. So that summarize the entire thing, right? And also tell you how powerful you can build things yourself, and also being able to customize what you are building end to end. All right, let's proceed. So have we talked about like the Interchain Token Service task contract, what you can do with it? It's cool to understand what are some things you should think about when you want to build, and also how do you even build? How do you get started? Yeah, that's why we are here. So, which is the demo about building it from scratch and then what you need to know. So, to the demo, first, let's talk about what we'll be doing today. But then before I start, mentioning what we want to do and then how we want to do it, this is a QR code here. If you scan this QR code, it takes you to the GitHub repository where you can find the full code, right? So in case during the process of live stream, you missed out on any point, or you just want to get up to speed, feel free to check the code. If you have any questions, let me know. And then also, in case you miss out on anything, you can find all of this, the code on this GitHub repo after scanning this QR code. So what are we going to do? We are going to set up our dev environment if we don't have it set up yet. We are going to write the tax smart contract with all of the customization that I mentioned. We are going to deploy to test networks. In this case, we're deploying to 2 networks. And then we'll write a script to test this contract implementation to actually see if it works. And of course, now test cross-chain transfer, because after inputting the fee mechanism, we want to understand that whenever we send this amount, the fee that we charge is successfully deducted after the transfer, right? So yeah, so let me switch right to my VS Code onto my terminal. So I believe you guys can see my terminal. Let me zoom in a bit. Yes, please let me know if you can't see my terminal. I'll be happy to, to increase it. But then, what do we want to do first? We want to create a new directory. Let me show it to my root folder. So I've created a new directory called Multichain Tax Contract with ITS. So you can call it anything you want to call it. But in this, in my example, this is what I've created, right? And after creating this, what do we want to do? Let me switch to my VS Code and show you what I have. So I've created this here. So after creating it, I want to be able to, I want to first create a new folder called token, but I've created a folder. Let me just see into that folder. So when you see ls, so you can find like this, but let me tell you what exactly I did to get to this stage. So after cloning into this folder, like after creating the token folder or cloning, I think, let me move this down a bit so that you see what my folder is. So this is my folder. I call this token, which is inside the entire directory. And then what we want to do is to separate our token implementation from the testing script that we'll be using at the end of the day. That's why we are creating extra folder. So now that I've created the token, you need to initialize hard So you can do that with npm hard init. So I've done that. Sorry, that's a typo. Hard. Yeah, so I've done that before, so I don't want to do that again. That's why you are seeing those node modules that I showed you guys earlier on, right? Which is this. So after doing that, you just initialize, hard hat, and then you'll be good to go. So Next, what we want to do is to install a few packages, right? Let me see. Let me double check if I have handout initialize. MPS handout init. No, type the wrong thing. Sorry. Oh, okay, yeah. So if you want to initialize add hat, this is what you should see. So after doing that, you just select JavaScript, just select the option all true, yes, yes, and then you wait for it to install. Right? Thought I've done this before. So it's good you guys can see what I currently have. So after installing this package, let's initialize add hats. So we have a few packages that we want to also install, which we'll be using during the course of building this contract. These are services like the Interchain Token Service and also the open contracts that we want to use. Okay, I think I'm getting those error because I didn't specify my MVM. So let's specify that. Let me move this, let me clear this and go up again. So let me just. So if you are not using MVM, then you don't have anything to worry about. So now we've installed, let's see list. We have everything here set up. What we need to do next is to install some of these packages that we need, which the first one is Axela Network / Interchain Token Service, and also the Open Zeppelin contract so that we can reuse some constants from the contract, and then .f and crypto. I'll tell you what we need crypto for at the end of the day. So I've installed that already, so I don't need to install. Next, we can head over to the code now. So this is what I have here. You can see I have my contract. I have my contract folder. Let me zoom in a bit so that you guys can see my screen even better. Yeah, so I have this contract. I have the log. You can see the sample contracts here already, and also ignitions and some other packages that we get by default. One thing that is not entered by default is the env file, which I have created. So if you check the env, I've created my env and then I've added my private key here. Of course, you don't want to leak your private keys or tell anyone, but this is the variable that I'm calling this private underscore key, right? And then all that, that's the only thing I set up differently. So next, what we are going to do is outside this token project, we are going to create a new folder, folder called util. And then what are we going to add in this folder? So we want to be able to, because we are doing this programmatically, we want to be able to interact with the Interchain Token Service. So we need to get the ABI for this service. So that's why we created this folder so that we can store our ABIs into it. So let me create the folder. You can call this folder anything you want, but in this example, I'm going to create a new file called token ABI, right? .json. So I have this Interchain Token ABI, which is going to be the ABI for our token that we deploy at the end of the day. And then number two, I want to create another file called Interchain Token Service ABI.json. Right. So this is this. So let me change this to so that we can have consistency with the naming. I have this now. Right. I've created these two files. So we don't know what Interchain Token ABI.json looks like right now because we have not even deployed our token, but we know what Interchain Token Service ABI is. So I can go ahead to go back to my browser and then go to Axela. Let me just go to our docs. So on our docs, if you land on docs, this is what you should see. Then you click on developer, you scroll down here, and you see contract address. Here, let me bring this up so you can see where I am, testnet. You click on the testnet, you scroll down. When you scroll down, you see the Interchain Token Service here. So you can click on it. So this is where we'll get our ABI from, right? So now I can click on contract, scroll down, read as proxy, click on the implementation contract because we need the ABI in this case. And then we can scroll down all the way down. You see the ABI here, and then we can click on copy. So now let's go back to our code. Let me make this bold. Yeah, so you can see my screen even better. All right, so now we have this, and then I can paste this in and click save. Right. So, but there's something you should note, that you can see that I have this in this way, like I have the array like this. Please note that, so it should, in case what you copied is not properly formatted, so that you don't run into any errors. So I have this for my, okay, no, sorry, that's a mistake. It's not supposed to be inside, the token is supposed to be inside the Interchain Token Service ABI JSON file. So save, pasting the same thing again, I'm saving. We don't know what the Interchain Token ABI JSON looks like, at least for now. But then when we deploy and compile our contract, we can get it and then update it later on. Right. So now we are done with this. We are done with all these. So what do we want to do next is to go back into our contracts folder, right? Our token folder, and then navigate to the hard config. But maybe let's just focus on the contract before we start with any config for deployment. So I have this contract now. I want to create our own smart contract, which is why we are here. So to do that, we can name it, in this example, I'll name it token.sol to keep things simple. And then we have this token.sol. What do we want to do first is to import some of the packages that will be. So I'm importing 3 packages here. First, I'm specifying the Solidity version. I'm importing the Interchain token standard. This is where we find some function that will be useful for us in this example, right? And also the ERC20 token, importing it from OpenZeppelin contract. We've installed that already, so we are good to go. And then the minter from the Interchain token service contract, so that we can be able to utilize the minter functionality where we can give minting permission, right? So to start with, we want to create this token to extend some of this contract. So we can call it this, and then we have the Interchain token standard, and also the minter, right? There are a few things we need to do. First, we want to declare state variables, right? These are our to-dos. Second, we want to set up constructor. Third, we want to also create a main function. I need to add. And then we also want to create a bond function, which are the typical ERC20 token function that you would find anywhere. And then we want to also create another function called add minter. Create add minter function that can allow us to, give permissions, like give mint access to any address to be able to mint tokens on our behalf. And then we also want to create a transfer from function that would override the default transfer form that we have from ERC20 token, so we can add our customization into it. And then we will proceed to create a spend allowance. So this is a function that will handle the allowance that we want to allow the contract to be able to spend on our behalf. And then we are overriding the default. So we are going to see all of that in a second. And then I think we are done with the call function, but there are also some other utility function you might want to add, like creating a function that returns interchain token service address. And then you also might want to add like function that creates a function that returns that chain token ID, right? And if you also have, the cool part is that if you also have other, utility or like functions that you want to add, you can, feel free to add it. And then next final one here is a function, like create a function that returns decimals, right? So these are some extra utility functions. This is just to tell you that you can add additional function apart from the default, method that you can find on ERC20 token contract and the standards. So these are the to-dos, and this is what we are going to do, right away. The first here, we want to declare state variables that we'll be utilizing in this demo. So what do we need to create? We need to create the token decimal. Of course, we want to pass in ERC20 token, so you can make it custom in such a way that you don't have to code anything within the contract. You can pass it in maybe from the constructor, or maybe you have a function that can update token decimal and all of that. We also have the variable for token ID. We have the variable for interchain token address. And then, of course, we want to have something that can take a few percent that we'll be utilizing in the contract at the end of the day. So that is why we are creating a few percent variable here. And then finally, the uint max that we are setting here. So just to make sure that we have this intact and it doesn't exceed the uint of 256 max. I'll show you where we are going to use that within the contract. So now we're done with the first task. So the second task is to set up a constructor. So what do we need to set up in this constructor? There are a few things that we need to pass in by default. So the first one here is we need to set up the name of the token, pass in the symbol. Our decimal value, in this case, ERC20 token is 18. Fee percentage, the percentage that we want to, charge for any tax that we are taxing our users, right? And then we specify Interchain Token Service address here. You can see we are passing that name and symbol directly to the ERC20 token here, and then we are assigning the decimal value that was specified here into our decimal variable here, and also passing the interchain token service that was specified here into our variable so that we can reuse it within this contract. And at the same time, we are passing the fee percentage here, right? And finally, you can see there's this function called add minter. What we are doing by default here is whenever this token is deployed, we want to add the message of saying that like, this person that triggered this call as a minter by default. So this is the only minter that we have for now, and this minter can give permissions to any other minter that we want to give going forward. So now we've done task 2. Moving to task 3, which is to create a very simple mint function that's uses the default mint function that we are importing from OpenZeppelin, right? So we have this underscore mint function here that just specifies the account that wants to mint and then the amount that we are minting. But there's something you should note here, that we are specifying that only a user that has this row can mint. So if your row.minter, if you have this row here, you should be able to, mint this token, right? So that's it for minting, which is our third task. The fourth one that we are going to do here is to create a bond function. Of course, make sure that your token is mintable and then bondable. So now we have bond function that can allow, so it's just basically the same thing with minting, but then we are specifying account and amount. But the only thing here is that we are calling the bond function to bond tokens from our contract, right? So now we have from the total suppliers, bonding token from the total supply. So that's it for the fourth one. So the fifth one, what we are going to do now is to create a add minter function. What is this add minter going to do for us? This add minter can give permission to any other address that wants to be able to mint additional token, or like that wants to be able to mint tokens, right? So it means that if you call this token, you can specify the minter, and then you can be able to add, this calls the add minter function by default. So you can add any address that you want to give permission to be able to mint, you can specify it here, right? Which is a very cool function that we can utilize throughout our contract. And then the next one here is to create a transfer form function. So by default, we have a transfer form function, but we want to override that function in such a way that we can customize a fee whenever a user calls, is being triggered. So we can customize a function there. But before we do like customize this transfer form, let's create a function that can specify, that can help us set the fee percent. I think this is important before we even try to use the transfer form. These are some utility, like some very useful function that you can call at the end of the day after deploying your token. So in this case, you can, of course, we want to make it dynamic in such a way that you can set a fee percentage by calling this function, and notice something here, that it's only an account that has this minter root can call this function and then set a fee percentage for it. So if you want, in case you are charging 2% and you want to override it to like 5%, then you can call this function to change this percentage without having to redeploy your contract. And then finally, now let's talk about the transfer form function that we want to customize. So here, this is where the actual action is, right? Where we want to calculate the fee that we want to deduct, and also deduct the fee from the total amount spent. So let's take it one after the other. So I'm going to create the function here. And as you can see, we have the function called transfer from, and then see we are overriding the default one, and it returns a Boolean true. So what do we want to do here? First, we need to calculate the fee. And then how do we calculate the fee? Is to basically use the fee percentage here, which was create a variable called fee, and then multiply the amount that is being transferred by the fee percentage. And then, of course, remember it's ERC20 token, so you need to divide by 1 times 10 by 18, which is the fee percentage. And then we also create like a variable to store, after the fee has been deducted, what is the resulting amount. Now we have calculated the fee. What we need to do now is to call the transfer from, to transfer that fee from and to the account that we specify, and also the amount that needs to be transferred. So we are calling super, because if you're familiar with the ERC20 token, you should see this is how you trigger it here. You call super, and then using super, you call the transfer from method and specify the account to transfer and to account, and then the amount to transfer. But that's not all. So this is where you can add things like, now that you've been able to do that, where do you want to send this fee, right? This fee that you charge the user, where do you want to send it to? So there are so many options here, which I'm going to add as a comment right away, where you know the list is very long, but just to give you an idea that in this tutorial, we are going to be burning the fee. But ideally, you can send it to a reward pool, you can send it to a treasury, you can send it to a liquidity pool. You can see there are a lot of options here, and the list keeps depending on your link, right? And then, so in this case now we can call burn, right? And then we specify which account, like from, that's the account, and then the value that we want to burn. This is the fee, right? And after that, that's done. So we can just return true, which is what the Boolean is supposed to return after implementation here, which is, you can see it returns a Boolean. So once this process is done, what do we need to do now? For allowance, the next task is create a spend allowance, function. So this spend allowance function that we are creating would overwrite the default one, right? And then to make sure that we are handling allowance correctly, and at the same time considering both the ERC20 token standard and Interchain token standard requirements. So to do that, it's quite simple. We just need to specify the spender, the sender, and the amount that we want to, give as an allowance here. So specifying the spender, the sender, the spender, and then the amount. And then remember, I mentioned we are overriding the default one. So in this case, we are assigning the allowance here, and then making sure that we can check the allowance against the uint max, which we calculated here. not to exceed, and then call the approve to approve the spender to spend this particular amount, right? So now we are done with the main core function. So other functions include returning the interchain token service address, which you might not really need, but in the case where you want to have like custom, implementation, instead of externally getting the address, since we're already using ITS here, and then during the deployment, we'll be passing in the ITS address, you can just call interchain token service address here by default. You can also return the last one, which is the decimal. These are additional functions, but our core functions have been implemented already. So now we have successfully implemented and then fulfilled all the tasks all the to-do that we created earlier on. And then we are good to go. Let me check if you have any questions before I proceed. Questions, and I think you guys can see my screen here. All right. Okay, so I think we are good to go. Next thing we want to do now is to set up our deployment so that we can deploy this token. So to set up our deployment, there are a few things. And set up your deployment if you have any particular pattern. I'm just going to use the normal pattern here. So yeah, GMP. Yeah, that's cool. So now we have the token. Remember, this is where we added the token contract. This is where we specified the token contract. Sorry, this is not the file. This is the file, yeah. Token contract. So what we are going to do now is to create our deploy script, and then inside the module folder, I'm going to create a new file called deploy.js. So inside the deploy.js, there are a few things we need to specify to be able to deploy our contract easily. So this includes like the regular way of deploying, but there are some parameters we need to specify. Remember our constructor, because we are using the latest and that. So you also make sure that we have everything set up here. So I'll specify this to keep things simple. I'm specifying the token called my token. We can name it my token. I'm specifying the symbol, which is MTK, for example, in this case. And I'm specifying the decimal 18. And I'm also specifying the fee percentage here. You can see that this is just per 18, and the result like 0.058 of the total amount that is sent. And then I'm specifying the contract, the ITS address. So if we go back to our constructor here, let's check our contracts one more time so that you see what I'm passing in and then why I'm specifying all of that. So this is the specification and name, symbol, decimal, fee percent, and then the interchain token service address. So where did I get this interchain token service address from? We can check it from our documentation. So if we go to our docs, this is the address I copied there. Just to be sure the address is correct, you can go back and then paste it in. Right, we have this address and then we are returning the token. So we are done setting up our script. Next, we want to do is to set up the RPC for us to be able to deploy this on testnet. Right, now that we are done with setup, like the token itself, we need to be able to set up our application to deploy. To do that, it's quite simple and pretty straightforward also. So we can just import a few things here, which number one is we are setting up the solidity version remains the same. We're importing our private key that we set up earlier on in our environment variable. And then we pass in the avalanche, which is the network. Here I'm using a public node. So I find the chain ID, doing the same thing for Phantom. So in this example, I'm deploying our token on both Avalanche and Phantom, and then connecting it and testing the fee across these two networks. So we are done with that. What do we need to do next is to deploy this particular token, right? If I'm correct, yeah. To deploy this particular token, so we can go back to our terminal. Anything again? Let me just clear. So what do we need to do to deploy this token? We can do that by calling the hard ignition to deploy on Avalanche and also Phantom. Remember, that's where we want to deploy on any chain. that we currently support, right? So I'm going to type in pasting this, which is nps adapt ignition deploy, to deploy our deploy.js. I mentioned deploy like 3 times. So to deploy our deploy.js, and then we are specifying the network Avalanche, right? Since I already set up, in case you don't have faucets, you just need to get faucets and from any free faucet platform, and then we can now deploy this. So in case you don't have, you run into an error, but if you need to get some faucets and then you'll be able to deploy. So now I can click yes, the script, and then wait for it to deploy. To ask to confirm I'm sure with the deployment, then I say yes. So it's going to compile the contract, and then it's currently deploying, executing the deploy module token. So now we should see our token address. So yeah, now we have the token address, which means it has been deployed successfully. We can go back to our Visual Studio Code, open up our script here, and then let's just keep the token address because we'll need it later, right? Avalanche, and then the next one is Phantom. So we'll do the deployment now on Phantom. So let me go back to our terminal and then just do the same thing, but we'll change the network this time around. It's going to be Phantom. And it's going to double check. Do we want to deploy? Yes, please deploy. So now it's going to deploy the token now on Phantom, right? Because this is where we want to send our assets from, and then we want to be able to deduct the fee. You can test with multiple chains. You can deploy on multiple chains and then follow this guide to connect those tokens together as a multi-chain token, and then deploy your charge your fee. And you should be rest assured that once you deploy all the tokens on this different platform, you can be able to like deduct fees across all these chains. So you don't have to worry about like going to these chains individually. Since you already deploy it and then you connected them as a multi-chain token, you can just leverage that to deploy token managers and also do your transfers, and the fees will be deducted by default. Don't worry, I mentioned token manager for the first time. I'll tell you what token manager is after this deployment. So this is deploying, it's taking a bit more time. Not sure what's going on, but maybe this might be due to RPC. But while that is deploying, let's confirm our token was actually deployed on Avalanche truly. So I'm going back to the browser, going to Snowtrace, right, which is the testnet explorer for Avalanche. Yeah, I'm going to now paste my address here to verify we have here. So you can see 2 minutes ago, right? This is our deployment, our contract creation token we deployed went through successfully, and we can even check from here the token here, right? You can see we deployed the token successfully, the decimal and every other details that mine is quite empty right now because we have not minted any token. We only just deployed it, right? So let's go back to. All right, so now this is successful. Let me just move this up a bit. So this is successful now. We can copy this also and then paste it inside here so that we can keep it for later. So now we are done with our contract deployment. Our token have been deployed successfully on Avalanche. Woohoo! And then we are also on Phantom. So what we need to do next is to write a script to deploy a token manager to help us manage token across different blockchain, and also write a script to do interchain token transfer. So what I'm going to do here is to create, so I don't need to create anything, I just need to make sure that I'm in the root folder. So I'm just going to go back to my terminal, clear my terminal, we have everything saved. Let me move this down a bit and then make sure I see the out of token because now we've done our deployment. So what I want to do here is to initialize hard hat, right? Because this is what we want to use to write our script and then test our contract. So you can just do that by installing let me do that with clear this. So install npm install -- save dev, and then add hat. So I'm specifying 2.18 because this is what I want to use. Of course, you can decide not to specify any version. And then I'm going to install that. I think my network went off a bit, but looks like I'm back. Yeah. So let's see. Let's try to do this again. Yeah. So if anybody can still hear me, please you can drop a comment so that I can know you guys can still hear me. Because I think I'm back now, yeah. Yeah, so this is taking forever, but then depends on just acting weird. So I should have installed this before, but then apologies for the delay, guys. So now we're good, so we can continue. So now we've installed add hats, and then I think we are good to go with the next step, which we need to initialize an empty config here. So to do that, we can just say npx add hats. So nps add that init, just like what we did to initialize our project earlier on. But then note what I'm going to select right now. I'm going to select empty add hat config, right? Because that's just what we need. And then we can go back to our project. You should see the empty add hat config and package.lock installed. But there are a few packages we need to install here for us to test this script. So we are going to install .env Axela.js SDK for our gas estimation, and then the add hat toolbox, right? So let me go back to our code and then clear this up. Yep, I'm going to paste this right now. So just to make things faster, I think I copied the wrong thing. Oh my God, 9. Yeah, I got you. And then we can just, this is just a simple npm install command. So we are going to install .env to manage our environment key, and then the Axela.js SDK for gas estimation that can estimate gas during the process of deploying token remotely and also doing interchain transfer. And finally, we have the toolbox that we will be using in this project. So I'm quickly going to install that. Remember, we are still on the root project. Let's just wait for this to install. Hopefully my internet will do this faster. So this should be fast depending on your internet. Let's have this installed now. Clear. So now we have what we need installed. What do we want to do to start with the script. We can just go ahead inside root folder. I can create a file called index.js because we are using TypeScript. You can use TypeScript. Oh my god, I think I spelled this wrongly. Index.js. Right. Next. Oh, right. So we have the empty index.js file that we can utilize here. So what are the things we need to do inside this index.js? Just like we added, tasks like to-dos for the. So let's add a to-do to note some of the things that we want to do in this file. But maybe we can just import some variables here so that we can move faster because of time. So we need a few things. We need a few packages. So we've installed Hard Hat. We've installed we have Hard Hat installed already. We've installed crypto, and then we specify this environment. We import like the AcceleRJS SDK, and then we also import our ABIs. All of these things are importation, right? So we import our ABIs, and then the Interchain token address, specify a variable, and specify a variable for Avalanche and Avalanche Phantom token. So these are old deployment. So we need to replace this with our new deployment. So let's go back to our token deploy script. Inside this token deploy script, we have the Avalanche token address that we just deployed. So we can copy that and then head back here and specify it, go back there, paid it for Phantom. Yeah, so I have, so now by this, but there's something we did not add the other time. If you remember, we didn't add Interchain Token Contract ABI because we don't know what the ABI is, right? So now we need to add it. Let's go to since we have deployed it, so we can find, if you go back to the only thing we need, go back to the use folder here and then paste it in. But then if you paste it in and try to save, if you have any formatter, it will flag it because it's not correct. So you delete this ABI, make sure you have this square bracket, and then at the end you also have square, because it's JSON, doesn't take command, so you can install. So now we have our token ABI implementation that we can interact with. So we are with that. Go back to our index.js file. We have everything imported. So you might be wondering, what exactly is this lock and unlock fee and then means bond? So I mentioned earlier on that we are going to use Token Manager. Token Manager is a contract that allows us to be able to move this token around. So Interchain Token Service, whenever you want to deploy or move assets from one chain to the other. That is why we are using Token Manager. But then Token Manager that we currently have has types. Let me go to our documentation and show you what I mean. So now, back to our documentation. Let me go to developers, cross-chain, and then go to Interchain Token. Click on upgrade. I want to show you what it is. So this is Interchain token.sol.type, right? So in this Interchain Token Manager types, we have different types. So in this type, you can see we have, I don't know if you guys can see my screen. Is it big enough? But let me zoom in. Anyways. So if you see this, you can see that we have, different types. The first one, native Interchain token. Remember, is enum. That's what I'm specifying. But what we want to use here is a token that will be locked and unlocked, like lock or unlocked at the token manager, and then which will account for any fees on transfer and behavior. You see the comment here, which is what we want to do, right? We are building a task contract. We want to attach fees into our contract and being able to do that across different chains. And since we'll be deploying the token manager for that, you need to specify the type of token manager. lock and unlock, and hence where I got that number from. So this is 0, 1, 2, 3. That's why I'm specifying 3 here. Then for mint bond is 4, which is why I'm specifying 4. So, but the reason why I want to use mint bond is I want to deploy a lock and unlock token on the source chain, like on the first chain, right? And then deploy a mint bond type on the destination chain. That's why I'm specifying mint bond. So depending on your need, you can customize which one you want to use. In this case, that we already have token deployed, right? We need to deploy a lock and unlock token manager type for that particular token, and then grant ITS the permission to be able to mint and transfer the token as needed. So now let's go to our implementation and then input some of the tasks that we need to do here in this file. So what are the things we need to do in this file? Because we are testing, right? We need to first create a utility function that can get our contract instance, because we want to we'll create an instance of the contract. We don't want to like keep creating. Once you just create a function, we can use that function across. So we are going to create contract, create a function for contract instance. Number 2, we are going to create a function that helps us get a function to get contract signer. 3, next we are going to deploy a token manager on Avalanche. Then next we'll deploy token manager on Phantom. Right. So when we deploy a token manager on Phantom, we are, after doing that, we have deployed on the first chain and the second chain. What we want to do next is to mint and approve. You remember that we just deployed our token, we did not mint any token yet. We want to mint a token and also approve ITS to be able to spend that token so that we can use token manager to transfer this token across different chains. So here, what we want to do now is to mint and approve, create a function that can mint and approve ITS. And then we also want to create a function to get a gas estimate, because when we are dealing with cross chain, when we want to start doing remote deployment or interchain transfer, we need to know like the gas that is required for that particular transaction to go through. So instead of coding gas, we are going to dynamically get the gas that will be required for the transaction to go through by just leveraging the SDK that we installed. And then now finally we want to be able to create a function to transfer tokens. So now these are all the things we want to do here in this script before we start testing them out. So let's go one after the other. So the first thing we've already imported. So we want to create a token manager, right? So we want to create a contract instance, like a function that will just create a contract instance for us so that we can dynamically be calling it throughout our application. So we have this, right? And it's a very simple asynchronous function that takes in the contract address, contract ABI, and the signer, and then it returns a new instance of that, details that we entered, which returns our contract instance for us. And then that's task 1. Task 2, we also want to be able to get like the signer. So instead of waiting like calling it as the get signers every time, we can create a very simple function for that to get our signer. And you can see that is just getting the signer. So each time we call this function, it will return the signer for us, and we can just use that, right? So now we are done with that. Third task here is to create a function that deploy and add a minter to the token manager. So you can name the function deploy and add a minter, right? This is what we want to call it, but feel free to call it anything you like. So inside this function, there are specific things we want to do. We want to be able to get the signer, the contract instance, the signer, and also generate a sort value that we can utilize. And at the same time, deploy, create a params and deploy the token manager. So let's take it a step at a time. So the first one, we want to get the signer for this transaction, right? So we can just call our signer and then we'll be able to get the signer. The second thing we want to do here is to get the interchain token contract, the interchain token service contract instance, which you can just do that by just calling get contract instance, and it's going to return the instance of this interchain token contract for us. Number three, we want to get the instance for the token contract so that we can call the interchain token contract, call the add minter function that we created earlier on the contract directly in this script. And then next, we want to generate a random sort value. So generating a random sort value is very, very important because your sort is a unique value that we'll be utilizing to create, to create the token manager, to deploy the token manager. So we need a sort value, a random value that you can have access to later on. Right. And then after that, we'll create a params, which is a requirement. And I'm going to show you that in a bit. So we are creating a params here. Let me move this up a bit and then move down to those. So we are creating a params here. And all we are just doing is specify the byte and the address, which is the address of the signer, and also the Avalanche token address, which is our source chain in this example. Next, we are going to call the deploy token manager function to deploy this particular token manager. Yes, so we click on contract. We can go to Interchain Token Service and then search for deploy token manager. So if you check this deploy token manager here, you see we have, the parameters that we specify there: salt, the destination chain, type, params, and the gas value, right? So let's go back to the code. I just wanted to show you what it looks like on the docs. So now we specify the sort, but we are not specifying destination chain because in this case, this is our remote chain. We are deploying on Avalanche right now. So when we want to deploy on Phantom, then we can specify that it's Phantom. But this is the first chain that we're taking our source as our source chain. So we don't need to specify any chain address here or a chain name here. And then we're specifying the type, which is lock and unlock fee, specifying our params, and specifying this random gas value. So usually you can keep this as 0, right? Because gas value here is used for like multi-core processes, especially for our interchain token portal. Should in case there's a particular core that require a multi-core, to be able to fund that core with a gas amount, that's why we're specifying this here, right? But in this case, we don't need it, but I'm just specifying it in case you come across this and then you want to use or you want to do any multi-core interaction at the end of the day. So now that we have this, what we want to do next is to get our token ID, because we'll be using our token ID also. This token ID is a unique identifier that is generated based on your signer address and sort value, which is why our sort is very, 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 very important here. So now we have the token ID, which you can retrieve by just calling interchain token ID and then specifying our address and our sort. Then finally, we need to get the token manager address, because this is a token manager. Of course, we want to know what the token manager address looks like after getting the token ID. So we also have a function on the contract that we can just use to call the token manager address and by specifying our token ID. Remember, I mentioned the token ID is a unique generated value for your token. And then after doing all that, we have been able, at this stage, we should be able to deploy, we should have deployed a token manager already, but then we want to also give permissions to our token manager address to be able to mint token, right? So which is what we are doing here, right? And finally, we want to log our transaction here. We want to log. There's some parameters that we will be needing throughout this implementation, and then we want to log some details so that we can reuse them later. I'm logging the salt, I'm logging the transaction hash to confirm the transaction, I'm logging the token ID, I'm also logging the expected token manager address so we can reuse it. It's important for you to know your salt. This salt is very, very important so that you don't lose control on your token manager that you're deploying, because this your token manager is what will be used to move token on your behalf from one network to the other. So after this now, we should test out our token manager deployment, right? Before we proceed to other actions like deploying token manager remotely on Phantom, approving ITS, creating a function. Um, so we can test bit by bit before we deploy. So let me scroll up and see we have now. So now I can enter. I need to let me go down a bit. Don't know if you guys can see. Let me take this up. So let me go down a bit, and then I need to add like a very simple method that we can call to deploy our processes. Right. So in this case, I'm just going to paste in everything, but then so as not to confuse you guys, let me remove these ones that we don't need right now. So this is a very simple function that we just want to use to test this. And then we are calling this name, we are setting the default to here. So if you specify a function name that is not, by default accepted, then it's going to fail. So our function is this, right? And then we have this. So now we can go to our terminal to test if this works as expected. So going back to our terminal, have like we just need to run the function to be able to deploy this. And remember, we are deploying on where? On Avalanche. So I can specify this. We specify the function in which is deploy token minter, token manager, and add minter, and then npx run and that like add that index.js, and we specify the network. So now I can click enter. So it says Avalanche does not exist. So let's go back to our config and make sure we have Avalanche specified here. Oh yeah, we did not update our config yet. So the same way we did for our token, let's do that for the script also, because we are using add for both, right? So, and then specify this and then paste it in, right? So we should be good to go right now. So we have the network specified. So I can go back to my code, clear this. So we have a clean state, sorry. And then I can specify this function name and then click enter. Am I entering a different name? Set invalid account for this, please configure. Just did that. Let's make sure we are not missing anything. Network this, and then okay, yeah, this is our config. I think I have everything. What could have happened? Received undefined. What's that? So let me check the index.js. Did we miss anything? I think this is okay. Clear. Not sure what's happening. Let me try to run it again. Avalanche. Invalid account for network. Did we mess up the network here? What could we be missing? In my config file, I think let's see. Oh, sorry, this is not config file. We have everything set up. What did I miss? I'm not sure what are my so maybe you guys can see that already. But then let's see, let's work together. Invalid network, I have everything configured. Did I miss anything here? Didn't miss anything, so I can go back. Invalid account for network is, yeah, private key, yeah. Oh my God, thank you, thank you, Bilal. Oh yeah, that's true. We forgot to start private key. Oh my God, how did I miss out? So now we set up private key for this, but we forgot to set up for the main script, right? Thank you so much for pointing that out. Yeah, so now we have private key set up. Thank you. Um, it's crazy. Yeah, so I now have this. Let me see. Yes, I think the script is running now. We should see our salt and every other thing. Um, okay, because this is deploying on chain, usually faster anyways, but let's see if in as much we do not get any error. I think we should be good to go. Oh, yeah. Now we have it. We have the sort value, we have the transaction hash, the token ID, and then the expected token manager address. So we can copy this. All right. Thanks, Bilal, for pointing that out. So we can check. Let's log this so that we don't miss it. We can paste this in here. We'll be using our token manager and the sort value later on. So I have this here just to save things, right? So now we're done with deploying token manager on Avalanche. The next thing we want to do is to deploy token manager on Phantom, right? Which is our remote chain in this example. Don't forget that you can use any other platform, like any other network that we currently support. And we support over 64 chains. So there are lots that we covered already. So what we want to do next is, since we have deployed on Avalanche, we want to before we deploy on remote chain, we want to mint token and also give approve ITS to be able to send that token. Remember our approval method that we added. So what we are going to do is to create a method called mint and approve ITS, which we can add here. Let me scroll this up. Let me bring this down so that we can have a clean state. So I can paste it in here. And then we have mint. We are doing typically the same thing here, but the different what is different here is that we are now calling mint. Remember when we deployed the token, we did not mint. When we deployed the Interchain token, we did not mint anything. So now we are minting, and we are minting to this address, and we are minting 1,000, right? And now we are approving ITS address, which is our Interchain Token Service address, to be able to spend this amount, and we are just keeping it to max. You can decide which amount you want to approve ITS to spend. So next, to test this out, we can go to, we can create a case for this. And then in this case, it is going to be the name of the function that we created, which is mint and approve ITS, right? So mint and approve ITS, and then we'll specify the function that we want to call here. In this case, still the same function here. So you can decide what any way that you want to deploy your script, right? But this is just a simple way of making things really clean from the JS standpoint. And then after that, to test this project now, we need to go back to our terminal. We have this already. We can now call the other function here to mint and approve ITS. And then it's typically the same thing, just that we are calling a different function here, right? The first one we call deploy token manager and had a minter. The second one we call mint and approve ITS. So now I can click on this. So while that is loading, we can go to our browser to confirm the previous one that we deployed. Testnet. It's not trace. Yeah. So the first one we did two things, right? In fact, let me copy my address instead so that we can see all the transactions. I need to enter my okay. Yeah, I want to copy my address that I'm using for this deployment and then just check that address instead so that we can see all the transactions that is happening right now. So we can see the two transactions that we did. We deployed token manager and then we added a minter, which is the ITS address. So now we just minted 1,000 tokens. So let me duplicate this page. We minted 1,000 token. You can see that 1,000 token was minted here. And then if we go back to the transaction page here, you can see we then approve ITS, right? Approve function was called, which is also successful. So we should be able to see, we should see that our transaction is successful. You're already seen that on this node trace. It says minting and approving ITS successful, right? So now let's go back to the next task, which is, okay, I think we've done this already, mint and approve ITS. Let me take this out and then just bring it up here. So what we want to do next is we are going to create our tax. Oh my God, what did I copy? Oh, sorry. Just making sure that we don't lose track of steps. Right. So now we've done that. What we need to do next is gas estimates. So because we've deployed locally on the first chain, which is Avalanche, we want to deploy, we've minted and approved ITS. Now we want to do things remotely. So we need to pay gas. So for you to pay gas efficiently, not to overpay, even though if you overpay, whenever the transaction is completed end to end, there'll be a refund process, even if you overpay. But why overpay when you have a GS SDK that can estimate the gas that would be required for that transaction to go through? So for that to happen, we just need to create a very simple function called gas estimate, right? And then what this function is going to do for us is to just call the API, call the estimate gas fee on the API, specify the source chain, the remote chain, and then the currency, the gas limit, and then the multiplier here. So you can simply just do this. Once you do this, anytime we call this gas estimate function, it's going to return the required amount of gas that is needed for the cross-chain, the remote deployment to happen or interchain token transfer to happen, right? So we are done with that. We don't need to test. We need to deploy first so that we can call the method for gas estimate. So now that we want to deploy token manager on Phantom, let me move this down so that we can have a clear view. So deploy token manager on Phantom. We are going to see something like pretty much similar to what we did for deploying on remote chain, but there's going to be a slight difference. I'm going to tell you what the difference looks like right now. So we are going to do the same thing by, sorry, I keep pressing enter to bring this up. Let me take this down again so that we have a clean state. All right, so the first thing we want to do is to be able to get like signer and also instantiate our contract instance, like get the contract instance here, which is what we did here. You've seen this before. So we got like the interchain token contract instance and also the interchain token service contract instance and also the interchain token contract. Right. The next thing we want to do is to create a params, but in this case, our params will be pointing to the destination chain token. Remember the first time we wanted to create these params, we specify Avalanche token address. So it's pretty much the same thing, but we are specifying Phantom here, which is the remote chain, right? So if your remote chain is base, for example, you can specify the base token address here, right? And now we want to call the gas amount. We want to create a variable called gas amount, and then this is going to call with the gas estimate function that we created, right? Gas estimator, right? So with this now, we can get the value, the gas that is required for that token, remote token deployment to happen, right? And then we can go back to call our remote token deployment again. Let me bring this down. So we can call our remote token deployment again. In this case, we'll specify, in this case, we'll specify the token manager that we want to deploy remotely. We are calling the same function, but there's a slight difference here. Here we are specifying the sort. This is not a new sort. This is the old sort that we got from the previous deployment, right? And then let me just scroll up, and what we logged earlier on, where is it? So here, your sort value, you can copy it here and then go back here and then paste it in. Make sure you're using the same sort value so that this will be seen as the same, linker. And in the first one, we didn't specify remote, but now we are specifying remote, and then we are specifying phantom because that's what we want to deploy. And then we are specifying the interchain token manager type. In this case, we are deploying means born, right? Not lock on unlock or lock on lock fee, right? This is means born type. Specifying the params, passing in the gas value again, which I mentioned earlier on. And then the gas amount that requires for this cross-chain call is what I'm passing here. And then that's the function that we want to create to deploy our token manager. So we'll do the same thing again. We'll get token ID and then the token manager address. So let me update this sort to make sure we are using the same sort value here, right? And then now we know our token ID, and we can use our token ID to get token expected token manager address. I'm going to log this so that we can confirm that this one and the first one we got is the same thing, and also the token ID, right? Because we are using the same sort. And then finally, like we did earlier on, we need to add token manager as a minter, and then we want to log some information that we can cross-check, right? So I'm adding token manager address again as a minter, like we did before when we were deploying on Avalanche. And then now we finally need to log some information. We are logging the transaction hash, we are logging token ID, and then the expected token manager address, right? So it's about time we test our implementation before we proceed. So we can go back, let me check, see the name we call this, deploy token manager remotely. And then we can create a case for this. And this case would be this, and I'm going to call await and then specify the function that I want to call, and of course break. So once we are done, it should break automatically. Okay, I think I didn't specify this. Yes, so we have specified this now, so we can proceed to test this particular remote token deployment on Avalanche, because we are deploying from Avalanche to Phantom, right? So I can use the same script, but then calling a different method here, right? And then click enter. Token manager should be deployed remotely. Yeah, I'm waiting for this to run. We should see, yeah, you can see we have transaction hash. And then if you compare this token ID, see this token ID that you are currently seeing on my screen, and then the token ID we have before, you can see it's the same thing because we are using the same sort value and then the token address, right? And then the expected token manager ends with 9A7. We also have the same thing, which to tell you that is unique. As you deploy to different chain, it's going to give you a unique address all through. And finally, after doing that, do we need to confirm transaction? Yeah, transaction is successful. We can just check our address here. Sorry, that's the wrong one. Let's go back to my wallet address. You can see this happens 49 seconds ago. Add minter. We're able to add a minter, which is on a remote chain here. Right. We deploy token manager again. Right. 55 seconds, 49 seconds. Token manager here was deployed on, from Avalanche to Phantom. Right. So we are almost done. Don't worry. The last one here is we want to create We want to be able to transfer our token. So we need to create a method called token transfer. And to do that, because we want to transfer from Avalanche to Phantom, so we are going to create a method to do that. Let me just close this up. So this method, we are getting the signer again, getting the interchain token address, and then the gas amount. And the most important method here is the interchain transfer method that we need to call from our interchain token service, right? So interchain transfer, let me delete this token ID. So we are going to specify the token ID, which is the one we stored earlier in the previous step. And then the receiver's address here, I'm specifying my own address, the amount, the person that wants to receive this asset. And then finally, amount that I want to transfer, I'm transferring 500. We minted 1,000, I'm transferring 500. I don't have any data I want to specify. That's why I'm saying OX. And then this is not fee. This is still that gas value I mentioned for multi-core, which you can also specify as 0. And then I'm passing the gas amount for this because this is a transfer between one chain to the other. We need to specify gas. So let's go back to our terminal here and copy the token ID once again. And then go back to our method and enter this here. So now we have this. What we need to do next is we pass in all of this parameter, but we need to just log this transaction hash so that we can be sure everything went successfully as expected. So finally, we need to test this interchain token transfer and actually see if our tax implementation works as expected. Yeah, so case, I have this. And then this case we are specifying here is transfer tokens. And sorry, I keep into colon here. You're not supposed to have a colon. There, we are supposed to have it here. And then I can say await this method. Let me take this up a little bit so that you guys can see my screen. So break, then I'm breaking this right. So click save. Now we've implemented this method. We just need to deploy the script as usual on Avalanche. So I can go back to my terminal. We can clear this now since we've saved all the information. So let me, so the only thing we are changing here is the transfer tokens. We are specifying the same thing. And since it's happening on Avalanche, we want to transfer from Avalanche to Phantom. So we can click enter. I think we are running out of time here. Let me see what happened. What happened? Okay. You said yes, okay. Let me clear this and check if I'm still on. Yeah, I'm still live. Yeah, so sorry. Let me go back a bit and then try again. Excuse me. Not sure what happened the first time, but let's see if transfer token works. So we've been able to implement end-to-end, but we want to test the actual implementation for our fee. So we said what transfer successful. So now we have the hash. So we can just go back to my account details where we have the log because I'm currently checking. And then we can see this function call here called interchain transfer. So if I click on this, we should be able to see the transaction here. So I want you to note something. When we were deploying, we specified that 5% should be like deducted, right, from the entire amount that we want to transfer. So now this is successful. You can see details, you can see every other information. One thing I want you to note is when the transfer was done from this account, from this chain, like this account to this, 500 was sent, right? By the end of the day, 475 was minted on the destination chain, right? Or sent to the destination chain. And then 5% of that amount was actually burnt. You can see it was burnt to 000 because in the contract we specified this, in case you missed that part. Remember that when we implemented this transfer from, we customized in such a way that after the fee is being deducted, it should burn that amount. But this is exactly where, if you specify any other address, then this is where it is going to burn, the amount from, right? After burning, it's going to send it to that particular address rather. So if you specify any address, in this case, we are just burning, we didn't specify. That's why you see that it was sent to 000 address because we are burning it, right? Which makes our end-to-end implementation complete. Woohoo! Yes. So now we have successfully implemented the contract logic and also tested it end to end to ensure that um, we can add tax to amount being transferred depending on needs, and then we can also specify where it should be transferred to. Right. So because yeah, I think we've successfully done this like end to end. So let me quickly go back to our presentation to round things up. Right. So I know you might have questions or you're seeing this for the first time. No worries. We support, we got your back. We have everything you need to help you. First, just Google Axelar support. The first link you will see is probably going to be the Axelar network slash support repo where you can create any issue and they will be happy to answer you and help you in any way. You can give us feedback, recommendation, question, queries, bug. Just let us know. We'll respond. And then we have the Axelar examples where we understand the value of creating resources like for developers, snippets that you can quickly try out to test things, or you need to just see how things are being implemented differently from what you have. You can find all of these examples here. And then yeah, finally, once again, my name is Idris Olubisi. Thank you for staying till the end and also following through. You can scan this QR code to give me feedback what you think about this workshop, how how important this workshop is to your own learning, and also help you understand the process of building a multi-chain task contract. And also it takes less than 1 minute to fill in, just like, trust me, you just fill in and then let us know. But then before I end, let me see if we have any question. In case you have any question, please feel free to ask. We are out of time already, but then I'll be happy to answer your questions. Even though you have questions, you can just go back to our repo. If you have any issues, just create it on our Discord. Also, we'll be happy to answer your questions. All right. Without any question, let me wait. 5, 4, 3, 2, 1. I think no questions. All right. Thank you so much once again for joining. Bye, guys.